Okay, now we're going to look at weighted mean and the mean of group data. So some data sets contain entries that have a greater effect on the mean than do other entries. To find the mean of such a data set, you must find the weighted mean, which that actually is the definition. So I'm not going to rewrite that. But we do have a formula. So our weighted mean is still X bar because it represents a sample, is the summation of each of our data entries times the weight, divided by the summation of our weights. Okay, and here W, again, that represents the weight of each data entry. So this is most commonly found when we're looking for the GPA, or if we're looking for like your grade in your math class, since we have weighted categories. So our example, you're taking a class in which your grade is determined from 5 sources: 50% from your test mean, 15% from your midterm, 20% from your final exam, 10% from your computer lab work, and 5% from your homework. Your scores are 86, 96, 82, 98, and 100. What is the weighted mean of your scores? So we're going to break this apart. So we have our test, our midterm, our final, our lab, and our homework. Okay. And with each of those, we have our test score, which is going to represent X, and we have our weight. So for test, our average was an 86, and our weighting for our test is 50%, and as a decimal, that'd be 0.50. Our midterm, we score 96, and that is 15% of our grade. Our final, we earned an 82 for 20% of our grade. Our computer lab work, we earned a 98, which is 10% of our grade. And then our homework, we earned 100 for 5% of our grade, so 0.05. Okay, so we're going to multiply these two columns together to find our X times W. Okay, so 86 times 50%, half of that is 43. 15% of 96 is 14.4. 20% of 82 is 16.4. 10% of 98 is 9.8. And 5% of 100 is 5. Now we want to find the sum of these last two columns. So the summation of W, or our weights, if we add those all up, we get 1. That is not always the case, so always make sure you check. And then if we add up our last column of X times W, we get 88.6. So if we find our weighted mean, we're going to take 88.6 divided by 1, which gives us an 88.6%. So if the minimum average for an A is 90, did you get an A? And no, you did not. Okay, so now we're going to go through the steps of finding the mean of a frequency distribution. And then we'll do the example of this together in class. Okay. So the mean of a frequency distribution for a sample is approximated by, and our formula here, our sample mean, X bar, equals the summation of X times F divided by N. Okay. and where X and F are the midpoints and the frequencies of a class respectively. And then remember N is our sample size. Okay, so our guidelines or our steps for finding the mean of a frequency distribution. The first thing we want to do is find the midpoint of each class. Then we're going to find the sum of the products of the midpoints and their frequencies. Okay, and our symbol for that would be the summation to represent sum of X times F for the midpoint times the frequency. Then we're going to find the sum of the frequencies. Which is going to be our N, which is the summation of F. And remember, that's our sample size. Okay, and then lastly, find the mean. And we just use our formula. So the summation of X equals the summation, or sorry, X bar equals the summation of X times F divided by N. The one thing to be careful about is our round off rule is going to be one more than the original. Careful to not do based off the midpoint.